Welcome everyone. The next session will be delivered by a Chinese over here, being me. Actually, this is a collaboration in between company Vivalyte, coming out from Belgium, which represent by myself, and also our friends Wisdom Lighting from China. The topic we are going to deliver is about how to solve the lightbox myth, which is especially about illumination. So I'll start with a little introduction of who we are, what we do, and come to a bit of explanation of the actual context, the technical content of this presentation, and we'll also share with you a little bit surprise at the end. So if you could stay with us for a few 20 minutes, let's say. Starting from who we are, Wisdom is actually a lighting design analysis studio, which is particularly focusing on lightbox designs. Coming from really light path design simulation, the company has been helping the big players like JCDecaux, Clear Channel, like CBS for many years in public media transport, those kind of media network. And Mr. Wang, as the inventor of the patent, has filed quite a few US patents, particularly on the optical design. And we as Vivalyte, we are a Belgian company located about 300 kilometers away from here, not too far from border, focusing really on helping customer, large format printers, sign makers in designing and delivering right illumination solutions with LED. And the sectors and customers we serve can be seen in this picture. Basically, we are covering public media, being, for instance, Clear Channel, JCDecaux, CBS. This is one of our installation. That is actually the double-decker bus for London, the iconic Boris bus. That's how the British guys call it. Next to that, retail corporate branding. That's more the large format visuals go for sign makers typically. Signage, really hardcore signage, channel letters, overhead light boxes, everything. Exhibitions, which is always there as a small part of the business, but critical, being visible. Interior design, which is also one of the growing part of this business for large format printing. Even in FESPA, they have now a new section about print interior. We see more and more nicely printed large format get into the interior and architectural business. So that's also where we serve with all different segments in the market. A bit of also customers we serve coming from Clear Channel, JCDecaux, Exterior Media, that's the current name of CBS, by the way. Daktronics, also the big brands such like Nike, such as BMW, Spar. Not all of them are our direct client. Typically, we help the sign makers or large format visual printers or shop fitters to serve them. So coming to the topic, the exact topic. The challenge now, we see plenty of lights in this hall, plenty of nice looking light boxes. Also every now and then people start wondering what is needed, why. When people, of course, when our direct customers like you guys get inquiry or tender, people also always ask to have nice looking light boxes, being slim, sleek, elegant, but it always comes down to price. Of course, price is important, and very often, besides the duration, the reliability, they also ask, yeah, but illumination, let's get some LED. We all want LED. But what is it? What exactly are they looking for? How should we solve that part of the puzzle? Is this the right LED that customer will be happy with all the color differences, with all the points, the unevenness, on all this large visual? This is public transport media, typically happening everywhere that you can see. What is right LED? Typically, there are a few technical terms that we should make ourselves familiar when we come into the specification. One of them is illuminance. So when people talk about brightness can be easily described with a technical term which we call lux. That defines how much brightness could be measured on the visual, either being 4,000 lux, being 3,000 lux, or 2,000 lux. Which one is correct? That is actually very much depending on the environment. Is that very lighted environment? Is that very dark, like in the middle of the night outside? That makes huge difference, because eventually people what get people, let's say, the eyes react to is the contrast. The light itself doesn't play any much role. And the color, that's the other question. When we often got the question like, okay, is that warm or is that reddish? Which color is correct? But whose call is that to define the correct color? A very common question come with that is, or let's say to help you guys, to help clients, how do you want to define your color? How the corporate identity is being designed, the graphics, the icons, how is that designed, the logos? And of course, the role of the lighting, as well as printing and all the substrate, eventually, as a system, should just replicate and reproduce what customers see, either on their graphical design, on their own logo, to make sure it's perfect reproduction. We're not creating anything, we just try to reproduce what graphical designer designed. So that's the color reproduction challenge. In this scenario, for instance, which blue is correct or which red is correct, that's subject to the customer. But it can be measured, just to share with you. Another critical challenge, especially on really large format, is uniformity. Uniformity is always the thing difficult to define. People say, okay, there are points, there are imperfections of lines and zebra effect or whatsoever. It actually could be measured, and the intangibles and the subjective matters could be measured. We have a formula typically by measuring the brightest spot and the darkest spot. We make an average, and then we divide the highest, the difference basically, delta in between highest and darkest spot divided by the average, then it comes to the uniformity. This is a visual with uniformity level higher than 90%. This is a visual of uniformity on about 60%. Obviously, you see the lines, which is making it disturbance, making it not easy to see what is actual message, what is actual graphics for the viewer, for the audience. And typically, a good visual, a good light box would have a light box, should have the contrast, should have the uniformity, of at least above 80% to 90% to make it perfect. That's the definition of uniformity. And on top of that, I think we missed one picture. The color, that's actually a little bit of the myth also behind. We could have different terms to define color, for instance, color temperature. In Europe, we see very often outdoor public media for the color temperature more goes to 6,500 Kelvin or higher. For the interiors, which is more common, coming to 2,700, 3,000, which is more warmish, like living room in your own house. Color rendering index, it's also quite a myth because the definition itself is even changing. But especially for commercials, typically higher color rendering index represent better how the food and stuff would look. And then it comes to all of this of what is the right color, which red or which green should be right. We could actually have physical tool, measurement tool and methodology to help customer actually to compare to what they have designed for. That is represented very often on what we call color coordinate, being the X and Y, so that each individual point is a unique point on the color spectrum. And all of those come to the conclusion to translate the subjective matters into something tangible to help the design makers or printers to better understand the customers. This is just one of those application pictures, which actually is a very bright wall, but with a good print, with a good illumination, good uniformity, you could see a high contrast to represent the coastline of Oslo. This design and installation in Oslo for showroom of BMW, by the way. And another picture, for instance, in airport, this is Shanghai actually, a perfect uniform white. This is actually what Dunhill want, and that's why they rent this space for the commercial. Those without the background of how to define uniformity, you have no way to answer even the challenges from the customer. Yeah. The other part of the presentation, we're going to share with you about different solutions. Different solution of illumination, meaning either the light should be coming from front, from back, from side, or what we call edgelit panel illumination. There are pros and cons. Engineering or technical point of view, there's no perfect solution. It's just a matter that you need to have either a bit of knowledge, the basics, to guide you, and if needed, of course, ask for professionals to get you to reach the right point for your customers. Front lit solution is very often used when you don't have any room behind. In this scenario, this is a train station. The light is actually hidden behind the bars, behind the rail. So the light is coming from front. And the typical scenarios where you need the front lit is when you have no space behind, when you want to fully exploit the full flexibility of mounting, either in the top or on the bottom. Very often what we have seen is the flags, big banners, next to the road or in front of company facade, very often using front lit. It's probably not most efficient, but at least it has the easiest installation. On the other side, because front light is always competing with ambient light, that easily help to wash out the contrast. So that's why the front light, very often you see a big spot, but you don't see what is on. That's the contrast issue. On the other hand, you also need rather significant distance to have a good coverage. Otherwise, you have a few spots or too many spots. Shadow, if you have people walking in front of the light path, that will become an issue. And when we talk about color, it's also more color sensitive. And in general, a lot of light boxes, when we talk about light boxes, illuminate from the back, from inside of the box. There are a few different solutions to do that. Basically, direct illuminate from the back, that's what we call backlight. Or you put a kind of LED strip or LED bars across the complete profile. That's what we call set light, which is gaining popularity, especially for retail tension fabrics light boxes or stand building. Edge light, that's another solution which is very specific. I will go a little more into the detail of each of the solutions to share with you. The backlit solution. This is actually rather easy. The light is mounted on the back. Typically, it could be only used for single-sided light boxes, large visuals. And there are also a few different ways of implementing the light box. Being either direct, so light modules, you see actually some of the light boxes with a strip of module just mounted on the kind of back panel, either debond or aluminum or even steel panel or wood. There are also solutions to help to reduce the spacing, reduce the complexity using either wide-angle lens. Very often people call that lens as batwing lens, stretching the light very much to the side and compress that on the front to help improve the uniformity. And this is one of those pictures of those LED bars with a lens on it. The other solution is with reflectors. Actually, in the large fixed installation for public media, there are also ways, instead of using lens, you could have built a better reflectivity for the back surface to improve the efficiency as well. That is not often seen on the individual signs, but for large network like GC-Deco, like Clear Channel, those guys could significantly benefit from the cost efficiency, not only on the investment, but also on the energy saving. For the backlight, the typical reason why you use that is stronger. Because it's dark, the light dark incline into the substrate, it gives the best efficiency for whatever the means of the other illumination solutions. It also easily reaches the uniformity needed for large format, because all of the LED modules are right behind the printing substrate. Highly efficient. So illuminance, the illuminance is the term to describe the brightness of the surface versus the power consumption. Among all the other solutions, backlight is the most efficient. And also, it is natural color reproduction. Why we say that? Most of the other solutions, you need to have a reflective surface. And that reflective surface could change the color. When you have direct light, the color is easy to be perceived as how the light source is. The challenges with the backlight, on the other hand, assembly. If you have a large box, you have to put still a bunch of module, and that is, especially in this part of the world, pretty much labor intensive. Often, it's also higher on capital investment on the absolute value. It's pretty much limited on single side. If you want to have double-sided or double-phase light box, you have to need to have a panel in between and mount on both sides. Some people does it, but it's not very common. Complexity. If you want to ship a box of 6 meter by 2 meter, for example, you have to ship the panel, which you have the LED module already mounted on or not, but that takes space. On the other hand, when we come to different solution being side light, this kind of LED modules or bars typically high power. That is being mounted only on the linear profile surrounded on the peripheric of a light box. That is one of the immediate benefit. Is a lot easier to mount and to be immobile. So that's why stand builders likes this solution very much. They can easily mount it, ship the profiles in linear on the length, and then put it on the stand. When the exhibition is over, they tear it down. They don't need to ship any big panels. Another big benefit is actually, as I said, easy assembly, easy installation, mobility, also lightweight. Because if you ship the big panels, the cost of shipping is quite significant, and also you need to have the strong manpower to mount the panels. Another strength is also optically. If the LED bars are properly designed with the right optics, it helps to still maintain very good level of uniformity. It's tricky point. For side light, typically it's more complex compared to backlight. For backlight, all the light comes through, and it's rather easy. You don't have to really control too much on the optics. On side light, if the light box is too big, for instance, 2 meter, 3 meter, 5 meters, the side light become quite a challenge. There you need to really have a kind of lighting analysis to help to design properly how to reach the right uniformity level. On the other hand, also the efficiency, because side light is mainly a kind of reflective kind of technology. Efficiency is lower comparing to backlight. Illuminance, so basically the brightness level is typically lower. And color reproduction will be highly depending on internal reflective structure. So that means although it's easier to build a light box with satellite, if you want to do it right, you need to still paint internal structure properly, reflective, matte, to help to make sure there's no or mitigate the shadows and the uniformity issues. So that's also the complexity part of the satellite. Just to give you an example, for instance, we have done recently a shootout with our product and also a product from a very big name in Europe. And when we put the LED on the side, typically for the satellite, you want to reach 90% of uniformity. Still remember the specification we have mentioned earlier. In this case, we measure 3000 lux, which is closer to the light source. We measure 2800 lux in the middle. And this complete setup is properly designed with the right diffusive layer with an internal structure and also with a good optics on the LED. This is same setup, actually the same diffuser, same structure, but the side light modules in this case was not long enough, not far enough. So in the middle reaches only 1000 lux, which is typically for a Xi or for a light box. Where do you want to put your visual? Where do you want to put your message? It's typically in the middle, right? So that's a bit of the complexity and challenge. So when you see, for instance, now the side light is becoming popular, easy to buy, easy to mount together, be careful. The optics is playing an important role, and it's not always easy to see from actual product. The best way we always recommend to our customer, try it out with your own profile, with your own visual, especially when it comes to more significant project. If you have a chain of 100, 200 shops, always wise to make a prototype, a pilot, just to fly to prove the concept before you actually get into production. If the production is already running, typically it's already too late to change. The last solution on the technical side is Hlight. The principle of Hlight is a little more complex actually, but actually we are all seeing a perfect example. Most of the modern current flat panel, television or monitor or display is with this kind of technology behind anyway. Only difference is from design making point of view, on us, we just use the panel as a surface lighting solution, a light source. And the digital television or digital screen like this, there's extra modulation to change the picture where you need it or want it. So the principle of this is actually there's always a plexi typically across the complete surface, which we do an optical treatment on one side of the surface. That treatment is actually pretty complex to make sure the light comes out from the surface properly in a uniform way, and light source is always on the side. This is the way to transform a linear light source into a surface light source. There are also different technologies. People talk about screen printing or laser engraving or V-cutting or diamond or scratching or engraving. So there are different technologies. Most of the small panels nowadays, click frames, snap frames, are using either screen printing or the lasers because it's cost efficient. When it's coming to the large format, maintaining the uniformity without black hole in the middle becomes a real challenge. That's where we use a different technology to have even smaller opening to have the largest possible format, which we can go even up to 6 meter by 2 meter for the size, which that is actually the physical limit of the material of the acrylic. This is just one of those example, a bus of the double-decker bus in London, illuminated with LED, Hlight, with surface illumination. Why they use this, I can share with you. With the panels, it's slim, it's lightweight. That's actually all the benefit that you can see. It's easier to assembly because it's lightweight. It doesn't need a lot of depth. For the vehicle, for the advertisement on the body of a bus, that is actually quite important. Mobility, because it's slim, that's easier to move around. And the total capital investment is still rather low. But optical complexity, especially when it comes to large format, to maintain the uniformity, that's again a challenge. On the other hand, there's, for the Hlight panels, it's difficult to let's say, to maintain still, for whatever technology, to maintain the right uniformity. And it's always limited in size because you have to produce a full plexi, a full panel. And we often have this kind of questions. Can we cut a panel, or can we just produce large standard panels and cut it, keep it in the stock, cut it for whatever the size needed? No, it's not even possible, or it's not optimum in this technology, because when you start cutting the panel, all of these optical patterns are gone. So you cannot maintain the same uniformity as how it is designed. So basically, I believe that's a bit of the technology of different solutions that we try to share with you. In case if you have more questions, we are reachable. Vivalyte and Wisdom Lighting, we are all over here, me and our fellow from China, Mr. Wang. We are a member of Belgian Sign Organization, which is also a partner of European Sign Federation. So we are pretty much on the forefront in illumination on LED, exploring the boundary, how to deliver, helping customer to deliver the right light boxes. If you need any help, come to us. And we have also a little extra surprise that tomorrow afternoon, 4 o'clock, 20 meters away from here, we have a Belgian beer ready for all of you. If you want to drop by, most welcome. And that's our part of the session. Yeah. Omar. Thank you.